Okay, thank you for the intro. Yeah, so we need to forget some things in order to make way for new things, right? But first, I wanted to do a quick intro and a little bit of history of the APK format. For those of you who maybe haven't been with developing for Android for 10 years. By the way, my name is Wojtek. I'm a developer advocate at Google. I work with Android and Android Studio to help you developers make better apps. So hopefully you'll be able to learn a thing or two to make your apps a little bit better. OK, so APK, the APK format. You probably all know it. It's just a zip file. When I presented this talk once at another conference, I actually had the full name of the acronym APK here, which I found on Wikipedia, and it said it stands for Application Package Kit. Then I went back to work, and I saw some Android engineers talking about this, and they said they don't really remember what it stands for. So don't trust everything that Wikipedia says, although it's highly probable. Well, anyway, it's an Android package, right? It's a zip file. It contains all the resources that we have in our app. Some examples of that are XML resources such as the Android manifest and the contents of the res folder. We have the resources.arsc, which is a binary file that holds the resource table with strings and some other things inside. It tends to get pretty big, by the way. And then there's assets where you can put any file in there. And there we have code. There's two types of code in Android apps. There's the DEX code, which is the Java or Kotlin code that you write that gets compiled into DEX files. There can be one or more if you reach the DEX limit. And then there's the lib folder, which holds any native libraries, so .sos, .dlls, if you use them in your app. And those can also be pretty big. And then there's some metadata that I will discuss a little bit later in the meta inf folder. So this hasn't really changed for 10 years now. So this format has been with Android from the very beginning. So just a quick refresher of why this kind of needs to change now, right? And I will talk about that later, about the new format that we've introduced. So this is the part of a resource table of a typical Android app. So at the top, you can see all the configurations that this app supports, which is HDPI screens, XHDPI screens, and so on and so forth. The problem is, when I install it on my Pixel device, it only looks at the resources for its own density, right? So it only uses part of the resource table, the resources available. And all of the rest, all of the other files is basically space lost. It takes up download size, it takes up disk space. There's nothing good that comes out of this for my device, but it will be used by other devices. And there are many other things that are similar in the APK. So like I said, we have native libraries in the lib folder, but your device is usually either x86 or ARM64. But usually we ship all of them, and only part of them will be used. Same with other resources in the resource table. So could we optimize that automatically? Could we just remove the files that we're not using when installing the file on our device, get rid of the native libraries, get rid of the other density folders from drawables, and so on? Well, theoretically, we could because it's a zip file. But the problem is in that meta inf folder that I mentioned before, because every APK has to be signed so that no one can tamper with it, so that when you get updates from the Play Store or from some other source, when you install them on your device, the system can verify that they have been signed by you, by the developer, the same one who made the app previously, and so that no data is leaked to some third party, so that you don't get viruses, and so on and so on. And the meta-inf folder contains these cryptographic signatures that prevent tampering with the APK. So funny thing, at some point, actually, you could remove native libraries, and it would still work. But that was actually a security issue. So we fixed it in some ancient version of Android, and you can no longer remove files without changing the signature. OK, so what can we do? So there's this concept called multi-APK. It's been supported by Android and by the Play Store for a long time. And what it lets you do is basically prepare smaller APKs that support specific devices, such as devices with MDPI screens and HDPI screens, and split your big, huge APK into these smaller ones specifically for a specific device. You can do that, well, first of all, let's start by screen density. This lets us get rid of all the big bitmaps, drawables, and you get X packages. Normally, it's even more than 4. It can be like 7 or 8. But then you think, OK, but I also have native code, so I would love to split that up as well, because my native libraries are like 10 megabytes in size. So I want to have specific versions for x86 and ARM7. So now you see the number of your packages that you have to build and manage and upload to the Play Store doubles. And then new Android versions come out, and you think, oh, I want to use this new feature, but I still want to support older devices. So I'm going to have 2 packages, and one of them is the older one for people with older phones, and this is the new great one using some great new feature. And suddenly you have 20, 30, 60 APKs that you have to upload to the Play Store. Well, you could do that through the API, so there are ways of doing this. But then you get even more possible variations. And the biggest problem really is not just generating them, because you can do that in Android Studio with the splits directive. So you can split automatically by density, by ABI. Studio will spit out all these 60, 90 packages, however many you have. However, you still have to manage version codes by hand. And this is hell. Like, if you want to version all of these files, and none of them can have the same version, they have to grow incrementally, and there are various rules that you have to follow in order to have the right files installed on the right devices, and suddenly no developer wants to do multi-APK anymore. And so we go back to the big, fat APK, and, well, users are not happy. And also notice that even though the command is called splits, I actually used quotes. And that's because when Android Studio introduced this splits directive in the Gradle file, multi-APK, that thing that I just talked about, became known among developers as split APKs because of the name of that directive. But that is completely wrong. And let me tell you why. So in order to actually generate splits and something that we properly call split APKs, there was, for a long time, a hidden command, a hidden directive in Android Studio that works together with the splits command called generate pure splits. The problem was we never talked about it because it was not supported by Play Store. It was supported actually from Android 5 Lollipop. It was supported by the framework. And that was about the same time as I joined Google. And one of my first assignments for my manager was, can I go and find out what this split APK business is about and go talk to the Play Store people and see how we can support it? So I was a noogler. I was like, on it. That's going to be the first thing I tell developers. So I went to the Play Store people and asked, do you support split APKs? And they said, no. Are you going to support them? And they said, maybe, not now. So a year passed, and my manager comes to me and says, so what happened to these split APKs? I'm like, hey, Play, do you support split APKs yet? And we're like, no. When will you support it? Maybe someday. We're busy. Well, of course, that's not exactly how the conversation went. They were actually super cool people. And to be fair, they were pretty busy. So they were figuring out a lot of other stuff. And so across the 3 years that I've worked for Google, we got things like alpha and beta tracks for testing your releases with real users. We got staged rollouts, so you don't have to roll your update to 100% of users, but you can test on a smaller group. We got store listing experiments. We got universal app campaigns, smaller downloads, faster updates. We got the pre-launch reports that tests every APK that you upload on the alpha and beta tracks for errors on multiple devices. And finally, we got Android Vitals lately, which helps you figure out performance problems and bugs in your apps. And a lot more. So if you're not using any of those things or you haven't checked them out, please do. So yes, the Play Store people were busy. And actually, it turned out that supporting splits was not an easy thing to implement. Contrary to what I thought as a naive noogler back then. So the first time splits were actually used by you developers, probably without you even realizing it, was about the time when Android Studio introduced Instant Run. And in order to have as fast an install time for the emulator for the devices, what Android Studio did is actually figured out which classes changed and which resources changed. And instead of pushing the whole APK to the device, it used this ADB partial install, which worked in tandem with the split APK system to only push the changes to the emulator as you developed. However, that never translated to any benefit for your users. It was only for developers to quickly debug and rerun an app. In the meantime, as time passed, app size became a problem. It was steadily going up and not as fast as storage on devices or as fast as internet connections or internet prices. And so at some point, the limit on the Play Store was 50 megabytes. It turns out that some very, very popular apps started reaching that limit and were very afraid of adding new features. And at some point, Play had to raise it to 100 megs. But developers started getting more and more interested in APK size and app size in general. I actually wrote a few articles about that. Developers liked it, and so I continued exploring that topic. And around the same time, apps were experimenting a lot with dynamic code loading. The problem was there was no officially supported solution by us, by Play or by Google. And the problem was that if you're trying to implement dynamic code loading, you will, at some point, create a security issue. So I'm not saying all apps that did it wrong, but there was just so many things you could get wrong, especially as a small developer without a huge security team and so on. So first of all, you had to host that code that you want to load dynamically somewhere. So you had to pull it down from your server. You had to make sure those files were secure. And then you had to actually make sure you're downloading what you put on the server and not what someone is trying to send you. So you had to use HTTPS. Well, believe me or not, some apps did not do that. They downloaded anything over HTTP. Then you had to roll out your own signing and verification. So I told you that APK files are signed, and you can verify their integrity. But if you just pull down a DEX file, you would have to do all of that by yourself. And you know what they say, don't roll your own crypto. It's just too easy to make a mistake. And then you would have to make sure that the file you downloaded actually stays secure on the device. Some apps put it on the SD card, so anyone could access it and put their own DEX code there instead, and then pipe out the data of your users somewhere else. And so you had to re-verify it every time you loaded it. So there's just so many problems. However, it's doable, and I will show you later how we solved it. So I said security is important. And so at some point, we also introduced a new app signature scheme for apps called V2. Now, the previous scheme, the previous signature, as I showed you, had all these hashes for all the files in your APK. But what it did is actually it hashed the uncompressed contents of the files. So that whenever you installed an APK on your device, if it was, let's say, 100 megs, it had to go and uncompress all of the files just to verify if the installation is correct. Now, the new scheme was not only more secure, because it was stricter and safer. It verified all bytes in the APK without looking at the files individually. It was also orders of magnitude faster because it didn't have to do this, the compression. It only went through the bytes of the zip file. And last year, we also introduced app signing by Google Play. Now, for years, it was on developers, on you, to manage your own signing keys. You had your private key, you signed the APK, you sent it to Play, and then when your app was downloaded to user devices, the device could verify that it was indeed signed by the same private key that you had. However, if you lost that key, if you misplaced it somehow, you could not sign any new updates. You could not update your app in the Play Store because it would simply not install on user devices anymore. And a few developers with a lot of installed did lose their keys, and they came to us, to Google, and they said, can you help us? And we said, no, well, there's no way for us to recreate that key for you. That's because it's meant to be secure. It's meant to be only known to you. Well, Play signing changes that. If you decide to give Google your key, you no longer have to worry that you will lose it. It will be stored securely and safely for you. And instead, you upload an APK to the Play Store, signed using a temporary upload key. Google then strips that key out, replaces it with your private key signature, and delivers it to people, to clients' devices. So that's great. And actually, around the same time, what that let us do was, for the first time, change the contents of the APKs, which we could not do before. As I said, no one without a private key could change anything in the APKs. And so we had a beta program announced at Google I/O in 2017 of automatic APK optimizations, where we could strip out those native libraries, we could strip out some resources, and deliver an optimized APK to your users. However, that wasn't ideal. This never stuck around for longer. This still used the old multi-APK system. It literally just took some files out and delivered the APK. Around that same time, we introduced a new concept in the Android app world, which was Android Instant Apps, now called Google Play Instant. And these were basically native Android apps that users could run on their devices without installing them first. There were some things you had to do with your app, such as you had to use runtime permissions, you cannot use some APIs, and then the way the user would access an Instant App was through a URL. So you had to support deep links and app links specifically, and the app had to be very, very small in order to install fast. So it had to be 4 megabytes or less. By the way, when I say install fast, notice that if you use the V2 signing that we introduced some time back, that installation could be really fast, and that's what enabled this new use case. That's one of the things that enabled this new use case. So I put the little stars there next to supporting app links and 4 megabytes because actually this year we started a beta program where instant apps can be 10 megabytes or less, and you can actually have URL-less instant apps. So you can, if you support an instant app without a URL, you can actually start it right from the Play Store page. Next to the install button, there's a try now button. By the way, there's a great session about instant apps tomorrow from my colleague Ben Weiss, so I'm not going to go deep into how instant app work. However, just a quick intro if you've never used it. So normally you have this big monolithic APK with all the code and resources of your app. However, your app can be composed of multiple screens, multiple features, as we say. Let's say we have a main screen and then a detail screen with, like, let's say, a list of articles, and then if you click on an article, you go and read the actual article, or maybe a photo gallery. So if you can refactor your code and separate these features on top of a common base where you probably have your networking code, stuff like that, and if you can separate that as a self-contained, smaller chunk of your app, you can actually, using a different Gradle plugin, you can build this as a feature APK and a base APK, and then you can have more of these. And if any combination of a base APK and a feature APK is less than 4 megs, or 10 megs once we make it official, then you can have an instant app. And it's the first time when, in order to make it easier for developers to reach that 4 megabytes limit, when you could see something like this. If you open your instant app artifacts produced by Android Studio, you would not only see your base APK and your feature APK, but you will also see tens of these smaller APKs for different screen densities, different CPU architectures, languages, and so on. And when an instant app is actually requested by a client device, what the Play Store would do is it would deliver those base and feature APKs, and then pick all the smaller APKs that are required to run on that specific device. Now, how do you enable it for Android Instant Apps? Exactly the command I showed you before, generate pure splits. And this is the first time where splits were actually used and delivered to users' devices to make apps smaller. And the Instant App bundle format is nothing else than just a zip container containing all the possible splits that can be put together to be installed as a working app on a user's device. The main thing about this is the splits were generated on your computer, on your development machine, before actually delivering it to the Play Store. So that Play Store didn't change anything. It just got a zip file, then selects a few splits, and delivers them. The Instant App bundle format is nothing special, really. It's just a zip file. It doesn't have any additional information other than the APKs inside it. So that gets us great. It's halfway through the session. So I finished with the history of the Android APK formats and instant apps and so on. This gets us to the new thing we announced at Google I/O this year, which is the Android app bundle. And this is a completely new publishing format. And by publishing, I mean this is the thing that you upload to the Play Store. However, it'll be used to actually deliver split APKs to clients' devices. Now, the different thing about this bundle compared to, for example, the Instant App bundle is that it actually preserves more information about your project structure, about the modules you have in your projects, about the targeting of various assets and code and resources that you have that is saved in metadata inside this bundle. And like I said, that is used in combination with a service we call Google Play Dynamic Delivery, where Play Store can ingest this Android app bundle and then create and deliver APKs optimized for client devices. And on Android L 5.0 and above, where split APKs are supported, it actually delivers split APKs, so the smaller possible parts that together will make up the working app. But it also supports pre-L devices where it actually generates a single APK, similar to the multi-APKs that you had to prepare by hand previously, and just delivers that to pre-L devices, so everything still works, and is also optimized. And it splits by ABI, density, and language. So that's something you could not do with multi-APK before. And I actually got a question from a friend in the audience today. Why do you do these language splits? Isn't this just like saving a few kilobytes? Well, no. For big apps, this can actually be megabytes of savings for data transferred and data on device. Some of the apps out there have tens and hundreds of translations and thousands of strings, and that's not something that can be easily just not supported by this. So this is great. Now we get all of that automatically. You don't have to worry about version codes, about splits, and so on and so on. So this is how the bundle looks like. I took this from our documentation page, and you can see it's a little bit different from the APK format or from the Instant App bundle. First of all, at the top level, it actually has directories that correspond to the modules that you have in your project. Well, it's not a one-to-one mapping. I will talk about it in a sec. But every bundle will have this base module. And this is where all of your library modules and, basically all your library modules are put together in a single Android application that's a base module that has all the assets, resources, DEX files, and so on, and native libraries, so that Play Store can pick and choose and target the devices from these files. And this gives you basically the size savings. But what we didn't talk much about before at I/O and up to this point is you can also have these dynamic features here. And that is the most exciting part about app bundles and dynamic delivery, at least for me. And I will tell you about it in a sec. But first, how do you actually build an app bundle? Let's start with just the size savings. Forget the dynamic feature module for now. So in order to convert your app into using this new format, you have to build a bundle, enable play signing, because Play Store has to be able to re-sign those split APKs on your behalf, and then upload a bundle. And to do that, literally, instead of building your app with assemble release, you build with bundle release, and you're done. There are no code changes. You don't have to do anything. Literally, just build a bundle, upload it to Play, and let dynamic delivery do its part. So that's great. In case you don't want Play to split on some of these dimensions, let's say your languages aren't as big as I said, and maybe there's no point for users to have internet in order to change languages, because if they only get one split with one language when they change the language of the device, well, they need a connection to download the new one. Maybe you want to disable that. You can do it. Instead of using the splits directive, you use the new bundle one. OK, so there's a little bit of configuration involved if you want to, but it's not needed. So let's talk about dynamic features. This is the most exciting thing. So dynamic features are feature APKs that you can build from your project that are installed on demand whenever your app needs them. So they're not installed as part of the base APKs. They're not installed when the user presses install in the Play Store. Your app can be smaller, but can still specify code that can be loaded on demand. So this is the dynamic code loading and resource loading that I mentioned before. So to build those, you have to have a module in your Android Studio project that applies the dynamic feature Android Gradle plugin. And it has some special metadata in the manifest that lets the build system know that it's to be loaded on demand. It has a title, and it has a split name. And that split name is actually that folder name where it'll reside in the app bundle. So how do you actually use those? How do you then do the dynamic code loading, and how do you pull them down from the Play Store? There's a new library, a new SDK you might call it, called the PlayCore library. And it includes two most important parts that you, as developers, will probably interact with. One is the split install manager, and the other is split compat. So first of all, in order to request installation of these on-demand features, use the split install manager. It's a pretty simple API. You specify which splits you want to install. So these are the names from the manifest that I specified before. And you ask it to start installation. Now, there's a lot of callbacks here that you get to be able to watch installation download progress, installation progress. You might get failures if there's no internet, and so on. I will not cover all of these. This is a pretty simple API, and we do have a sample for that I will show you later. But the important part is the other thing you have to do is to use split compat. So in your application object, you can either subclass the split compat application, or if you're already using your own custom class, you simply have to install split compat. And then once you load a dynamic feature, there are just a few rules that you have to observe in order to be able to access the resources and the code contained in that dynamic feature. So for example, to load any new assets that are brought in with the APK that you just installed using the split install helper, you have to remember to always create a new context. Simply recreate a new context. From that, you can get an asset manager, and that asset manager will be aware of the new files that have been installed with the new split. Similarly, for accessing any native libraries, so the SO files, the LL files that have been installed as part of a new split that was installed on demand, you simply have to load the library using split install helper load library. So previously, you probably had system.load library. Just replace that with split install helper. It will make sure all the paths from the new APKs are involved in this load operation. And then you can simply use it. It gets a little bit more complicated, or actually a lot more complicated, if you want to access DEX code that you just loaded using the splits. So the basic answer is you have to use reflection, because your base module probably doesn't know anything about the classes and interfaces that are in the new split. So if you want to access something from there, you probably have to use reflection, get the class, get the methods, and call them. However, when playing with this for the past few days, I figured out a few ways that made it easier for me. And I'm sure you as developers and we as we have this functionality available to us, we will come up with better patterns. But for now, let me show you 3 ways that I used it. So first of all, if the code that you need to access isn't actually an Android module, if it can be refactored as a pure Java module or Kotlin module that doesn't access any Android APIs, that doesn't have to be compiled with the Android Gradle plugin, you can simply refactor it to a separate module. Your dynamic feature will depend on that module. The dynamic feature can be empty. There can be nothing inside, but it will depend on it as an implementation. And then you can, from your app, you can depend on that Java-only module using the compile-only keyword, which means it will be available at compile time. So you get code completion. You don't have to use reflection. The IDE and the compiler know about the classes which are in that library. However, compile-only means they do not get included in the base APK. They stay where they are. They are only packaged with the dynamic feature, and they will be loaded on demand. So if you can do that, if you have a Java-only library or a Kotlin-only library, then you can use that. It gets more complicated where you actually have to use the Android Gradle plugin, and that's because compile-only is not supported when depending on Android libraries. So in that case, you could think of something like this. If there's some kind of interface that you can extract from the classes that you'll be interacting with, why not include that interface in your base module? It'll literally be an interface, so no method bodies, no code, nothing. It doesn't weigh much. And then have a class in the dynamic feature implement that interface. So that, yes, you do have to do reflection. You will have to create an instance of that class using reflection, probably. But then at least you can cast it to your interface and use it normally as you would from your code. So that's one solution. And then remember how I told you in the case of instant apps, when you refactor your app into separate features, often they're separate screens of your app, so separate flows that are started from an activity or a fragment and are self-contained parts of your app. If that's the case with your dynamic feature, if you're literally loading on demand some part of your app that's a self-contained screen, you can just launch it through an intent. And an intent doesn't have to know anything about the classes inside, about the methods, and so on. Just remember that you have to use the version of the creation of the intent where you provide a string and not a .class, because the IDE will not let you will not see that class. So if you can just start that intent, then the new activity from the new module will take over, and there will be no cross module calls. So great. These are just some of the ways you can do that. There's a sample on our Google Samples page called Android Dynamic Features. It actually uses only the intent way of doing things. So everything is a separate activity. It's launched by intent, but you can use it as a starting point and maybe experiment on your own. So I really encourage you to look into that. And there's a few other things I wanted to mention. So obviously, this is a new format. Google Play does all these crazy things about optimizing APKs, but how can you test locally? How can you be sure that what your bundle will produce are the right APKs and so on? There's an open source tool called Bundle Tool, which is actually used by Play to generate the APKs. Then you can run locally on your devices. You can take a bundle and tell Bundle Tool to generate all the split APKs and then look into them. You can even install them on devices locally. You can even ask Bundle Tool to get a configuration of a device you have connected via ADB and save that to a JSON file and then generate all the APKs just for that device. So you can test locally. It's great. And then one more thing. If you want to test, especially if you want to test dynamic features, but not only, there's a new internal testing track, similar to the alpha and beta channels on Play Store. However, this is meant only for you, for your development team. You don't give that out to testers out in the field. But what it gives you is it gives you instantaneous updates, so that whenever you upload something to Play, you will see an update dialog on your device in the Play Store within, let's say, 10 seconds of you uploading it. And by the way, you might have noticed I'm presenting from a Pixelbook, and I was like, this is actually the only device I brought here. And I was still iterating on my slides and on my code, testing out various scenarios right before my talk. And the thing about the Pixelbook is, right now, Android Studio and Android support is in early stages. So this is on development channel. And it doesn't support ADB, so I couldn't test on my device. And it doesn't support running the emulator, so I couldn't test on the emulator. So what I did instead, I just used the internal testing track. And actually, I had this change code, upload to Play Store, and then update on my device kind of development cycle. And it worked great. I didn't have to wait more than 10 seconds for the updates to happen. So since we still have 5 more minutes, maybe I can show you some demos. What can we start with? OK, so for example, this is the sample I showed you on GitHub. This is running here on the Android support on the Chrome OS. And yeah, the sample doesn't do much, but it lets you start things on demand. Do I have internet? I do. OK, so let's try that. Let's see how this can look. Now, if I press this, a new package will be downloaded from Play Store, installed transparently to the user without killing the app, without restarting it, and a new activity taken from that bundle will be started. And live demos tend to crash and burn, so let's hope this works. starting install, downloading, installing, bam. So this was installation on demand, new code pulled down from the Play Store and run normally as part of our running app. Same here with a Kotlin sample, and we can also start native code from native libraries. So this is a JNI running from a library pulled down from the Play Store. And we can even load some APK that contains some large assets, in this case, this huge text. So yeah, this works. You can play with this. Just remember that in order to test this sample, like I just did, you would have to change the package name and upload it to your own Play developer console in order to have Play being able to deliver these to you. OK, so there was this sample. Now, I wanted to show you the internal testing track. So here I have my Sudoku sample app that I've been working in my spare time. And so I built a new bundle. I incremented the version code. I built the bundle so we don't have to wait for it. And I uploaded it to the internal track. Let's go. Let's see. App releases. There's a new track here, internal test track. Edit release. I started preparing it. So there's my bundle. So the currently published one has version code 8. I uploaded version code 9. By the way, there's some pretty cool stuff you can do here with bundles on the Play Store. You can explore app bundles. You can see and download all the APKs that would be generated by the Play Store from that bundle. You can see the size savings for your app before using the bundle and after you start using it. And you can even download device-specific APKs. So if I, for example, search for a Pixel 2, I could download a zip file containing the specific APKs that would be installed on my device. So this is great. You can either use Bundle Tool, or you can use this if you want to have more visibility into the APKs that are generated. OK, but let's go back. Version name, release, review. OK, so here's my Play Store, and here's my Sudoku app. It doesn't have any updates yet, and let's hope this works. Start rollout. Oh, yeah, very important thing. Dynamic features are currently in beta, so this warns me right now that I will not be able to publish my app publicly as in the production channel. So right now you can test it in the internal testing track and your alpha and beta channels, but you cannot roll it out to your users. OK, so I agree to that. I confirm, starting rollout. And let's hope this works. OK, so it's published. And now we wait. Let's check if there are any updates. Oh, something else has updates. OK, let's give it 5 more seconds. And of course, it worked every time before. Nope. Well, let's go ahead and see in a few more seconds. OK, anything else I wanted to show you here? Oh, yeah, we also added very preliminary bundle support in the APK analyzer. So you can drag a bundle from, let's see, where's my bundle here? So you can drag a bundle and see it here. However, it's not fully supported yet. You can explore some things like the text code, but you will probably not be able to see resources, and you will not be able to preview the new PB files format. So we're looking into that. What you can do instead, as I said, you can use Bundle Tool to generate a zip file containing all the APKs that will be produced by your bundle, and then look into that. And let's see. Did I forget to click something in the Play console? Well, I'm sorry, guys, but no. I tried that literally 10 times today when I was developing. Maybe it was already updated. Well, one of the demos had to not work. Sorry? Scroll up where? Ah, yes. There we go. It was probably here all the time. That's me. By the way, just today, so like I said, migrating to an app bundle is just a few seconds. But just today, before the talk, I also managed to actually do the whole Sudoku board generation as a dynamic app, as a dynamic loaded module. So if you might notice, if I now press generate, Play Store should do a thingy, or not. Well, the demo gods don't like me today. Anyway, so what I did was, as soon as you install the app, you get only one Sudoku board that's pre-generated, and there's no like Sudoku generation code. Once the player selects generate, they wait for 5 seconds, a new module is installed, and they get infinite board generation. So that's just one use case. However, let's close the demos. They were not very successful. Well, let's go back to the slide, and this is the finishing slide. So in the future, so this is very early days for app bundles and dynamic delivery. However, in the future, we might see app bundles converge with instant apps. So we could imagine instant apps, you being able to upload a single bundle that has both an instant app and your normal installable app in it. We might see other types of splits and optimizations so that not only ABI, density, and language would be supported. You could imagine having different textures for different devices supporting different OpenGL versions, and so on and so on. One thing that doesn't work with app bundles right now is APK expansion files. So that is something also that's important for games. And we are looking into how we can make it work together or in a similar way as it used to before. And possibly, I'm not saying this will come, but possibly having Google Play signing might enable signing key rotation in the future in case your key gets compromised. And I'd love to hear what else you would like to see with Android app bundles and dynamic delivery. So thank you very much, and yeah, let's talk later.